Mechanical
Okay, sir.
properties of solid. Clear?
Yes,
So
sir.
we have learned like what is rigid body. So rigid body is a body. What we have learned, like really, what we have learned, rigid body means what is rigid body?
The rigid body, they like they are different from point body, composed of many point masses.
Yes. And what is the condition like in rigid bodies are solid? Okay.
Mm, okay.
Whose shape size does not change. That is ideal case. Shape size does not change. Clear? But actually in reality, the shape and size is going to change. If you ask me like this mobile phone, clear? If I
Okay,
ask you
sir.
like this mobile phone, if I compress, it looks like shape and size does not change. It looks. But when I compress now, when I apply external force in the real object, like real solid object, there is some compression, there is some deformation. Little bit different deformation will be there. Okay.
Okay,
So
sir.
when we apply external force, when we apply external force on a solid, external force in case of mechanical properties of solid, this chapter we are saying deforming force. Okay.
Okay, sir.
Deforming force. Okay.
Okay, sir.
Practically, there is some change in the shape and size. Clear? If you apply any deforming force in practical life, deforming force change the body shape and size. Okay.
Okay, sir.
Body shape, size. Clear? Now write down the next. What do you mean by elasticity? Elasticity. What is that? So if I ask like elasticity means like you have a rubber band. If you elongate a rubber band, it is again come back to its initial position. Okay. That is the
Okay,
elastic
sir.
behavior. Like if you take a rubber band, if you stretch and remove the deforming force, then it again come back to its initial position. Clear? That is known as elasticity. There is one more definition. You please tell me if I apply a force on an object. Clear? If I apply a force on an object, if it is regaining its shape and size partially, then we say it has more elasticity. Okay. So
Okay, sir.
elasticity has two definitions. Yeah, so you must have clarity. So write down first definition. Elasticity means the tendency of write down the tendency to oppose the tendency to oppose any change in its shape. Any change in its shape.
Okay, sir.
Clear? Shape,
Okay.
size by a body. Clear? Second, the tendency of a body the tendency of body means molecules of an object. Body means molecules of object. Molecules of a object. There are two definitions of velocity. Okay,
So second, what is the second definition, sir?
I'm writing. This first velocity definition is the tendency to oppose any change in its shape. More the opposition.
Okay.
Clear? For example, you are having two material. If you are applying a force on that object, if one material is opposing more opposition. If you want to bring certain change, you are applying certain force. Then if a body is
Okay.
opposing that change in its shape and size, then if it is opposing more, then it has more velocity.
Then
Okay.
rubber band has less elasticity.
Rubber band and
Elastic.
steel. There are two things. Steel is more elasticity than rubber. Why? I will tell. I will tell after this. So
Okay, sir.
elasticity means the tendency to oppose any change in its shape, size by a body. Here, second definition
Okay,
is the
sir.
tendency of a body means the tendency of molecules of a body to regain its original configuration. Original configuration. Configuration means shape, size.
Okay, sir.
Original configuration after removal of deforming force. Okay,
Okay, sir.
but it is this definition. Second definition is valid up to its elastic limit. Okay, this definition is correct. The second definition which I have written, it is
Yes,
correct
sir.
up to its elastic limit. Okay, up to its
Okay, sir.
elastic limit, this definition is correct. Second definition. Okay, it is not
Okay, sir.
valid always. Clear?
Okay.
I will explain. Meaning is that, for example, you are having this is rubber band. This is made up of rubber. Length is, for example, 2 meter. If I take it is made up of steel, same length. It is 2 meter. Okay.
Okay, sir.
Then if you apply a force 4 Newton here, 4 Newton on this steel wire, then which wire will oppose the change more? Which
Sir,
body has more tendency to oppose? The tendency to oppose
steel.
any change in its shape, size by a body. Which body has
Sir,
more tendency to oppose any change?
steel, sir.
Yes. That is why you have seen, like, when you are applying a 4 Newton force, steel will elongate very less. Very less. But this rubber band will elongate more.
Okay, sir.
Okay. This is elongation. Why it is elongated more? If you apply 4 Newton on rubber, and 4 Newton on a steel has less elongation because steel has more elasticity, means it's steel. Steel body has more tendency to oppose any change in its shape, size. Okay.
Okay, sir.
And even if you remove this deforming force, this is what 4 Newton is. आज आज कोई दिक्कत नहीं. 4 Newton is what? Deforming force. Clear?
Okay, sir.
4 Newton means it is a deforming force. Deforming force is a force that will deform the shape of a body. For example, I am having this pan. Clear? If I apply a force on this pan on the top, clear? Then
Okay.
there is some elongation. So which force is responsible for elongation? That force is known as deforming force. Is it clear?
Sir, then it is same as potential energy.
Huh. Potential energy is different term. Okay. What I'm explaining, deforming force is a force that deform the body. Okay.
Okay.
It will deform. The force that will deform the body. It is external force actually, 4 Newton, but the name in mechanical properties of solid, we are giving the name that is deforming force. It is not an external force. Okay. Name is there.
Okay.
Here, the force which will deform, you can write the force which will deform the body. Okay.
Okay, sir.
Which will deform the body. I have many examples. Now, my question is, after removing this deforming force, why? Why the wire is coming back? Why the wire is coming back to its original position? What is the reason? What is the internal mechanism is going on? For example, if I ask you, this is the spring. It has its natural length L0. And once you apply a force, okay, its
Okay,
length
sir.
increase to L. When you apply a force on that, up to this you are applying a force, then because of applying this force, it reaches a length L. And once you remove this, then it regain its natural length. That is L0 is what? Natural length. Is it clear?
Okay. Yes, sir.
Now who is responsible who is responsible for taking this spring to again its original length? There is an internal force that is known as restoring force. Okay. That is
Okay, sir.
restoring force, FR. Restoring, understand it? Spring force. You have learned a spring force.
Yes, sir.
That is not restore means it will restore its initial position. Okay. Clear?
Okay, sir.
Is it clear to you?
Yes, sir.
Okay. Any doubt? Now I will explain you what is happening because every atom is made up of molecules. Clear? Every atom is
Okay,
made
sir.
up of molecules. So if I consider, if I on a molecule, if I take these are the molecules, okay, these are the molecules. Inside I have a spring, okay. Inside spring, what is that? Molecules. Or this is any rubber band, okay, rubber band. These are the molecules of rubber band, okay.
Okay, sir.
Let us suppose. And all the molecules are at their position. All the molecules are at their position. They are fixed because of intramolecular forces. Clear? Is it
Okay,
clear?
sir. Yes, sir.
1 minute, okay. Clear? So I am denoting that intermolecular force with the help of spring. Okay. This is the spring
Okay,
which
sir.
I am denoting here. Just to make you understand, this is the intermolecular force I am denoting. Okay, this is internal structure I am drawing. Okay.
Okay,
And
sir.
the molecules are at a separation of R naught. What is the separation between these two molecules? R naught. Okay.
Okay, sir.
This is known as intermolecular separation. Intermolecular separation. Okay.
Okay, sir.
Here also R naught. Here also R naught. Okay.
Okay, sir.
This is R naught is an intermolecular separation. At this intermolecular separation, energy is minimum energy. Okay, all the particle has minimum energy. That minimum energy, I'm talking about what? Potential energy. Okay, because potential energy, it is an energy due to its configuration. Here, which energy they are having? Potential. Okay, P. Clear?
Yes, sir.
This is like what? Intermolecular separation are not. At this separation, energy is minimum. When particle has minimum energy is minimum, then it has maximum stability. Okay, everybody wanted to be in stability, stable form. So it has maximum stability. That is why if you apply a force, if you apply external force on this, then this R naught will increase. Okay, when this R naught will increase, then energy is going to increase. Then again it will regain its original shape. Why? To increase the stability. Okay,
Okay, sir.
understood?
Yes, sir.
Okay, any doubt? Tell
No,
me.
sir.
So when you are applying a
No.
force, when you apply external force, then to gain again stability inside, this spring will elongate. There is a intermolecular force will be like this. Okay, understood?
Yes, sir.
If you apply like this horizontally, okay, understood?
Okay, sir.
Then a spring force will
Yes,
be
sir.
like this. Spring force simply means restoring force. This is known as restoring force, FR. Okay, up to this any doubt?
No. No, sir.
It is inside I am telling, restoring force. Now the same thing I will explain how this energy is minimum, the curve. This curve is very, very important. Like to draw this curve, I think I have explained it before also. This curve, potential energy versus intramolecular R is what? Intramolecular
Sir, I
distance.
can't. Sir, I can't understand a distance differentiation between potential energy and deforming energy.
Potential energy and
Deforming force.
see, potential energy, it is energy. Deforming force is different. The force which will deform. This force, when you are applying this force, the spring will extend. It will deform. Deform means like this. How will I explain like this? So
Okay.
see here. If you have a cube, okay,
Okay, sir.
bottom surface fixed. If you apply a force, then what will happen? This cube, after some time, little bit deform like this. Top surface,
No
okay,
worries.
will deform little bit. Theta. Bottom is fixed. So this force has deformed this. Deform is change the shape of the object. That's why it is known as deforming force. Clear?
Okay, sir.
And once you remove this force, then it again come back to its original configuration, that is Q, this Q. Okay,
Okay.
understood? Now I
Yes,
will
sir.
draw what is potential energy. It is the energy associated due to shape, size. Okay, understood?
Okay, sir. Yes,
Here
sir.
all molecules are fixed. You can check. All molecules are fixed. Understood?
Yes, sir.
These molecules are fixed. So they are fixed because they have potential energy. Some energy is being stored here. That's why they are fixed. Huh? Initially, you tell me rubber band. You are looking rubber band. Somebody has done some work to keep these molecules at this R naught separation. Okay.
Okay, sir.
What will happen? I'm telling. What is this? This is one molecule. This is second molecule. Initially, separation is more than R naught. Clear? When you are bringing these two molecules at R naught,
Mm,
then sigma bond pi bond is going to form R naught separation because energy is minimum. They are making a bond. Okay.
okay, sir.
So this intermolecular separation, they are forming a bond, chemical bonding, which you have learned. Because here maximum stability is there. That's why the atoms are coming closer. Otherwise, they are not coming. They never come. Why atoms are coming closer and you are looking the rubber band, you are looking a human being. We all are existing. You, me, everyone in this universe, we are made up of atoms. Electrons, protons, neutrons. We are stable because atoms. Why molecules are forming? This is just understand why molecules are going to form because every atom wanted to be in a stable form. That's why they are forming a sigma bond and pi bond. They want minimum energy, maximum stability. They want it to be in R naught separation, all the atoms. That is known as intermolecular separation. Understood?
Yes, sir.
Now potential energy curve with this R. R means what? R is the intermolecular distance. Intermolecular distance. Okay. So draw this potential energy curve. Okay. Draw this. Okay.
Okay, sir.
You can check here. Potential energy is minimum. Here positive potential energy na top. This is at this energy. The potential energy is minimum. And at this potential energy minimum, what is the separation? This is R naught. Okay.
Okay, sir.
When you are increasing, when R is greater than R naught, okay, when R is greater than R naught, then what will happen? What will happen? When R is greater than R naught, you can check. You are here. What is our potential energy increase? You can check. In negative, value less is more. Okay.
Okay,
When
sir.
you are having this separation, it is R is greater than R naught, then potential energy is maximum. Okay.
Okay, sir.
You can check at this curve, potential energy curve. Then it always try to regain its original configuration. Why? To gain R naught. To gain R naught. Then what will happen? From here to here, it will reach towards equilibrium position. Here. This is known as equilibrium position that you have learned. That is stable position. Clear?
Okay. Okay, sir.
Here bond is going to take place. Bond formation takes place at R naught. Here you can check potential energy is minimum only where? Here only. So maximum stability. Here stability is maximum. Maximum stability. So always we want R naught. Okay.
Okay,
That's why after removing the deforming force, it regain back to its original condition. But remember one thing, within the elastic limit means what? You should not apply deforming force that much high so that it is not able to regain its original shape. Sometimes you have seen like when you are applying a force on plastic, then it crosses its elastic limit. What is elastic limit? Elastic limit is a limit in which before that, before elastic limit, before the elastic limit, the body is regaining its original shape and size 100%. And after elastic limit, then it is not gaining its position 100%. Okay.
okay, sir.
There. So if you are, for example, I'm having this wire. Okay. If I apply a force on this wire, then this wire will elongate. I know that. So once I remove this applied force, then what will happen? It will regain its original shape 100% when it is under elastic limit. But if you are applying a force much greater, it is outside the elastic limit, then it will not regain its original shape. You know, in the bridges, you know, bridges, the bridge over which many vehicles are moving. In Chennai, you have seen so many
Okay.
bridge.
Yes, sir.
In the bridge, we are using spring. Have you seen springs? When vehicles are moving on the bridge, the bridge is little bit compressed. Then again come back to its original shape. I think you have observed or not. Bridge is also doing compression. Again come back to its original shape. We are using steel bars. Have you seen inside that?
Yes.
Okay. Sometime what will happen like when bridge become old, then its tendency to regain its original shape lost. That is known as elastic fatigue. You have learned elastic fatigue. Okay, you will learn a lot of things I'm
Okay.
having. But today, now I will start stress. This is clear to you?
Yes, sir.
Okay. What is stress? Stress is what? Write down. It is the internal force, means it is the internal restoring force, restoring force per unit cross section area. Okay. Per
Okay,
unit
sir.
cross section area. Okay.
Okay, sir.
It is the internal restoring force per unit cross section area. If you take a rod, this is the rod. Okay.
Okay, sir.
If this is the cross section area, here if I apply a force F external, this is the deforming force. Okay. Okay. So because
Okay,
I
sir.
have applied a force F external, then you are applying 4 Newton. Then it will extend some little bit. Okay. I don't know what is the original length, but I have applied F external because of that. It will extend little bit. This is the extension.
Yes,
Let
sir.
us suppose X. This is the original length. L naught. Let us suppose. Okay.
Okay, sir.
So you are applying that much force, it will extend x. X is a elongation. X is what? Elongation. When you are applying F external, there is the elongation x. After this, you are not applying. You are simply apply 4 Newton, let us suppose. So because of 4 Newton, this body is going to elongate, let us suppose x. This area of cross section. A is what? Area of cross section. You tell me, if you apply 4 Newton only, area of cross section is A, then it will extend x. Do you find any further extension? You are not increasing the
No, sir.
force. Do you find any further extension?
No, sir.
Tell me, I'm asking you, you are applying a constant force. Okay. For example,
Okay,
4
sir.
Newton only. Then do you find any further extension in this?
No, sir.
Very good. You are only applying 4 Newton force, and it is having the extension x. There is no further extension in this rod. It means why? Somebody is pulling you from the inside. Okay. Somebody is pulling you on this same cross section area. Somebody is pulling or applying opposing force on you. That's why you are not able to extend much, huh? Okay. Why you are not able to extend much? Because somebody is applying opposing force on you, like rubber band. If you
Okay, sir.
extend, somebody is pulling you inside. This is known as restoring force, FR. Okay. So
Okay.
under static here equilibrium means there is no further extension. Clear? This is known as
Yes, sir.
static equilibrium. Static equilibrium. At static equilibrium, what will happen? This FR is equal to what? F external. Okay.
Okay, sir.
It means what? At static equilibrium means like this is restoring force. Restoring force. And this F external, we are saying what? It is deforming force. Okay. Deforming force. Do you know? If you remove this F external, if you remove this F external, it will again retrace back to its original length because of this FR. This FR is doing what? It will take this rod again come back to its initial position when you are removing the deforming force. When you are not applying deforming force, if you remove, if you release, okay. If you release,
Okay,
then
sir.
what will happen? This FR will take this rod again to its original position. That's why it is known as restoring force. Clear? So I am denoting this sigma. This is sigma. Stress. Stress is what? Force, that is restoring force, which is equal to external force divided by area. Okay. 99% of the question you will find this only. Okay. This is the same thing you will. Is it clear?
Yes, sir.
So sigma is what? Is the stress. Stress is force per unit area. Stress. Okay.
Okay.
This stress is a which type of quantity? It is neither vector nor scalar. It is a tensor quantity. You will learn when you are
Okay.
adopting BSc physics now. Then you will learn tensor quantity. It's a tensor quantity. Okay.
Okay.
Clear?
Yes, sir.
Okay.
Okay, sir.
After this, write down types of stress. Types of stress. First is longitudinal stress. Longitudinal stress. It is of two types. It is of two types. One is tensile stress. Tensile stress. One is compressive stress. Compressive stress. Okay. Now see.
Okay, sir.
Tensile stress means you are having the rod like this. Tensile simply means you are doing extension. You are taking a rod, rubber band, and opposite force you are applying like this. It is going to extend. Okay, length is going to increase. Tensile means when you are applying a force like this. You are pulling from here, you are pulling from here. Okay, this is the area of cross section, this is the area of cross section. Clear? Then when you are applying, then inside restoring force will develop, which will restore. This is known as tensile stress. This is known as tensile stress. Okay.
Okay, sir.
It is what? F by A. Understood?
Yes, sir.
This is tensile stress inside. Okay, clear? Compressive stress
Okay.
means when you are compressing a body. This is a body when you are compressing it. This is a deforming force when you compress. When you compress, then in which direction restoring force will act? Like this. This is restoring force I am saying, okay?
Okay, sir.
Under static equilibrium, both are equal. Here compressive stress will be F by area. This is area cross section.
Okay.
Understood? So if you elongate any object, then stress will be longitudinal stress. If you compress, there is a compressive stress. Okay, this is area of cross section.
Okay.
Clear?
Okay, sir.
One is shearing stress. Shearing stress. Tangential stress. One more name of the same stress, tangential stress. Okay.
Okay.
Shearing stress, tangential stress. What is that? Simply when you are applying a force parallel tangentially to the surface. This is the surface, for example, a cylinder whose bottom is fixed. Okay.
Sir, here it is longitudinal stress or next type of stress?
It is not long. Longitudinal is previous. This is longitudinal. When you are
Okay, sir.
applying a force parallel to the axis, if this is the axis of cylinder, okay,
Okay, sir.
it is parallel to axis. You can check axis. Then we say longitudinal stress. Okay, parallel to axis.
Okay.
But in case of shearing stress, you can check on this cross section. This is the surface. On this surface, you are applying a force parallel to this, parallel to the surface. Okay.
Okay.
So shearing stress, tangential stress, when the force is tangent. Okay. When force is tangent to the surface, or we say cross section area. Okay.
Okay, sir.
Then here what is stressed? Because you can see molecules initially like this here when it is not stressed. After some time you will observe what this it will go like this. Okay.
Okay, sir.
This molecule will extend like this because when you are applying deforming force, no.
Okay.
These molecules initially straight. Okay.
Okay.
Then this is the extension. Okay.
Okay.
This is the extension. Delta x. Let us suppose length is L. Okay.
Okay.
Okay. This is the theta. The tan theta, if I write, tan theta is what? Perpendicular by base. Okay.
Okay.
You can check. Okay. So it will like sharing stress when force is parallel to the surface. Deforming force is parallel to the surface. Okay.
Okay, sir.
Then we say, then how to find like this deforming force or sharing stress tangential tangential force we will take. T means Ft means tangential. Okay. Area.
Okay.
This area is a Ft is what? Tangential force. Clear?
Okay, sir.
Any doubt?
No,
I
sir.
have various example like, for example, if you are having cube like this. Tomorrow also I will take your class. You have holiday tomorrow?
No, sir.
So evening I will try, but actually I have one IIT class also. So this, but I will try, okay? Your
Okay,
example, I
sir.
will try. This is the surface, okay? Surface area A. Now you are applying a force like this or parallel to the surface, okay?
Okay, sir.
Then what will happen? You will see like that. Initially it is straight now. This is our cube. Okay,
Okay, sir.
this is our cube. Understood?
Yes, sir.
If this cube is having the length, side length L, and this is the extension delta x for this much change. If you apply a force, and this is L, okay?
Okay, sir.
How much this theta? Tan theta will be perpendicular by base. I will tell what is that. When this theta is less, what is the meaning that? I will tell later, okay?
Okay, sir.
If you remove this tangential force, here Ft is tangential deforming force is what? F, which is parallel to surface. If you remove this, it again come back. The cube which you have showing the initially, it is initially
Yes.
before deformation. You will gain the same after removing the deforming force. Similar way like volumetric stress. Today we will complete only stress part, basic. Okay.
Okay, sir.
Tomorrow strain. Write down volume stress. Okay.
Okay, sir.
Volume stress. Continuous class I will take. Okay. In coming days.
Okay.
Volume stress means simply when you are taking any object inside water. Have you seen like in a sea? In a sea, if you take any object inside sea, then what will happen? Because of heavy pressure, there is deformation in the shape. Okay. If you take
Okay, sir.
any shape, any like any water bottle, any body inside sea, then because of heavy excess pressure, there is some deformation in the shape. Okay, like say deformation. Meaning is that the liquid molecules will apply a force on the surface like this. Okay.
Okay, sir.
The liquid molecules will apply a force on the surface of an object. Because of this, there is certain deformation, the size will decrease. Okay.
Okay, sir.
This force is going to act on this area. Okay, understood? Understood?
Yes, sir.
If I take
Got
unit
it, sir.
like this entire, if I take this is the area A, A. Okay. Then here, like, what is that? Here, volumetric stress is force by area, that is pressure. So, in the water, it is happening like pressure. Actually, force by area is pressure. You will see body shrink, certain change in volume. Delta V. Clear? Now, stress
Okay,
part,
sir.
actually, I don't want to go much depth forward. Tomorrow, we will go in depth. We will solve numerical. We will learn what is Young's modulus of elasticity, what is shear modulus of rigidity, what is like compressibility. Clear? What is bulk modulus? Today, I just complete only stress and basic. What is like internal structure of how this stress is going to develop. What is elasticity? Clear?
Okay, sir.
Tomorrow lecture, I will take your continuous lecture, and hopefully morning I have a class. So evening I will try around 6 o'clock. You will come by
Okay.
5 o'clock now.
Yes, sir.
So I will take around that. Be ready, Dinesh.
Okay, sir.
Okay, this chapter we will finish, and your exam will be very good. Okay, no need to worry.
Okay.
Things, try to learn the things and understand the concept, because once you understand the concept now, everything is easier. Nothing is tough.
Sir, I'm interested to study this, sir, but I'm studying very slowly.
That's why I'm going very slow now. I didn't teach today, actually, you understand. I didn't teach you like strain part. I didn't teach you like what is Hooke's law. I didn't teach numerical today. Reason is because I know small capsule I will give you in one shot.
Okay.
I will not complete this chapter. This chapter is very like not easy. This chapter is like short. After stress, that is a strain part. After strain, some curve is there. Then numerical, then energy only. Potential energy, energy stored in a due to strain. Okay, then this chapter is finished.
Okay.
This chapter, this properties of solid, mechanical properties of solid has wide application in bridges. The person who is going to, if you want to go in mechanical engineering, or if you want to go civil engineering, mainly civil engineering, you will find more application from this chapter. So when you are constructing any bridge, you need a lot of knowledge from this chapter. This stress part you will learn there only once you adopt civil engineering. Okay.
Okay.
So thank you so much,
Okay.
Dinesh. Take care. If you have doubt in
Mm,
any of the topic, you can ask me. Okay.
Okay, sir.
So thank you so much, Dinesh. And
Thank
tomorrow
you, sir.
hopefully we will meet and we will discuss the new topic. Okay.
Okay.
Thank you. Bye. Good night.
Thank you. Good night.